Welcome back, everybody, to episode 3 of Reason is Reality.
I'm Jay.
And I'm Steve.
I think we got quite a bit to talk about today, don't we?
We sure do. Today is our space episode.
Oh, sweet. I love space.
Yeah.
I think many people were fascinated by space.
Yeah. Yeah, unless you bump your head off the firmament.
Oh, yeah, well, we'll probably get into that a little bit later.
Yeah.
But for the most part, space is very intriguing. We don't know a lot about space, but there's a lot of people that put their life's work into trying to understand our galaxy and what's really out there.
Yeah. NASA, as well as a bunch of other organizations, are trying to figure that out and keep coming up with more discoveries and more data all the time.
Well, a lot of people think that NASA's just a conspiracy theory, though.
Yes, they do. There's a ton of them. That it's all meant to just trick people and draw them away from the truth of God and His creation of the universe. Oh, yeah? So, to start with one thing we got that's pretty interesting and pretty new. Stephen Hawking's he came up with a new theory on black holes. And, what we know about black holes so far as our research and everything has gotten us, black holes are very dense, and they say not even light can escape it. But according to Stephen Hawking's, something can escape from a black hole. Or at least linger at the edges, they say, because the center of Stephen Hawking's his new theory is that black holes, though they were for the longest time thought to be featureless and beyond mass and spin and the angular momentum of them, there was really nothing much they could determine about it. They were kind of considered to be like, I don't know, featureless blobs of physics. There was no way to tell us, how they formed. There's nothing we've been able to definitely see that would give us an idea of how they're formed. However, Hawkins comes up with a different idea. He says that black holes leak radiation over time, which we kind of know.
Right, because he came out with his, they have the Hawking radiation thing where it's like the radiation around the black hole.
Right, yeah.
Like, I mean, before you could say, I'm going to get sucked into a black hole, you would die from the radiation before you even reached the actual black hole itself.
Yeah, and if you could reach it, it would just take all your molecules and compact it into something so solid and tight that it would turn your whole body into a microscopic blob of all the energy and everything you're made of. It would literally crush and solidify you. You'd never make it through a black hole and come out the other side. That's virtually at least impossible. But so Stephen Hawking's theory says that something, even if it's bits of radiation, can escape from it, or at least linger kind of at the edges. It's the way he describes it, it's kind of like I think, as he said, it was that if you take what they call a soft photon, or a photon that has no charge, and introduce it to the black hole, the soft photons, they tend to change the angular momentum of black holes, because it's photons that have no charge, positive or negative, so it doesn't go like polarly to either positive or negative.
Right.
So what happens is, when it changes the angular momentum of the black hole, it allows us ways to determine what created that black hole, or what got sucked into it. what it states is that with these soft photons, or these photons with no charge, they kind of wind up in strands, or like hairs, so to speak. Just like long strands of zero energy photons that would contain sort of the history of that black hole, and how it formed.
Almost like the hair on our heads.
Sort of, yeah.
Sort of.
Yeah, and they kind of say that it would contain the whole history of the black hole, and the universe is full of black holes. So what they think is that that these little hairs, these strands of these photons, they kind of work like a hard drive, if you will, containing all of this information about how the black hole formed and the material that it pulled in, also showing how, therefore, the universe formed.
Mm-hmm.
And so what comes out of that is that they claim that if you can do it right, you should be able to read the materials and molecules in these uncharged photons, and sort of read them like the rings of a tree. So you know how, like, when you look at the rings of a tree, the rings will be closer together or farther apart, and these things denote, like, was it a warm season, a dry season, or was it a really wet season? You can kind of tell how the seasons were, and outside influence affected that tree.
Right.
Well, it's supposed to work the same way, according to Stephen Hawking's new theory, that you can see what was going on or going about during the time that the black hole was sucking these different things into it. And it leaves these little traces of it in these sort of linear strands of these photons. So, according to them, if we could read it correctly, it'll give us infinite knowledge of how these things formed and how the universe formed and what it's all about and made of.
Wow,
so,
that's freaking awesome.
Yeah, it is. And, Stephen Hawking is working with several other people on this theory, all of them super educated,
Right,
so
yeah.
they do know what they're talking about. The more we figure out about our universe and how things work, and if we ever have the ability to read the components and whatnot of these strands, we might know a heck of a lot more about our universe, like literally what came together and became other things, became other materials, and created everything out there around us. And it's not because somebody was bored with pottery and decided, I'm going to make a planet. Really? Wow. Well, how about I go and make $1 million,
Like, why can't I do that?
Yeah, right. So all I can say is props to Stephen Hawking's, and I hope this whole study goes well, and I hope we learn a lot more about the universe, how it came all about, and how we came to be what we are today.
Right. I think even though it's right now it's still based on theory.
Right.
Just how everything kind of has a theory, and then things have to be tested, and so on and so forth.
Sure,
but
and they have to always keep gathering more information.
Right.
Because, they start out with a theory where they have a pretty good bit of data going on, and they understand how these things work, but they don't exactly understand how it all comes together and does what it does.
Right.
So there's probably going to be years, if not decades, more research. And they might not even come to a conclusion by the time Stephen Hawking's is gone. But for the simple fact that they've all been working on this and starting this, it's still pushing us in a forward and knowledgeable direction. So,
Right.
So I really love the way all these scientists that work for different organizations such as NASA and whatnot they give their time and spend their whole lives trying to learn things instead of reading the same old stories out of a book that was kind of meant for mankind in its infancy.
Right.
Because now we're able to understand these scientific things that back then no one could understand. And if you even talked to it around the common people back then, they would have been like, "What? Nail him to a tree." So,
Right.
yeah, because to them that's just offensive, and it goes against their blind faith and beliefs.
Yeah.
But I'm sorry, if we didn't have science, if we didn't have medical science, if we didn't have any of this knowledge of molecules, compounds, everything else, our medical system would not be where it is now, and people would just be dying of things that we could cure or prevent, or like using DNA to make sure that nobody is born with the autoimmune disease that causes type 1 diabetes.
Right.
That I unfortunately have. Well, I wish they would have known that knowledge back when I was younger. I would be in a lot better shape now. But I don't understand then this argument between the sciences and between religions and blind faith. And they're like, oh, it's this way, it's this way. Well, you know what? When you had children, did you deliver them yourself at home, or were they born in a hospital? If they were born in a hospital, well, then they've used this new medical knowledge and things like this to make sure that your baby is born healthy, to make sure that the mother doesn't go through some terrible traumatic thing where she winds up dead while giving birth, or if her and the baby would wind up dead.
Right.
So, you can't, whether you're a person of blind faith or whether you're a person of science, you can't deny these things are real and they work. And overall, everyone, regardless of what you believe, should be thankful that we are learning these things and know these things.
Correct.
Because nowadays, a lot more people survive through things, and cures are found and whatnot. So yeah, to all you people out there that think science is evil, well, you better think again, because someday you're going to need that.
Right.
Yeah.
I mean, somebody just laying over your bed praying to themselves. I mean, that's, to me, I mean,
Yeah.
That's not a form of medication.
Like, well, thanks for your prayers, people, but the cancer's still growing. It hasn't gone away yet. Yeah. So, I think the next thing, dealing with the sciences and space here, is the new planet that they found. Well, yeah. So, this new planet is out past Pluto by a good deal. Pluto, by the way, of course, lost its status as a planet because it is so small, and the density of it isn't quite that great either. So it's not even it's not fully a globe shape even. Mm-mm. And not only that, it's about the size of one of Neptune's moons. So they downgraded it to what they call a dwarf planet. And there's a couple things that kind of categorize a celestial body as a dwarf planet, and that is, one, that they're smaller than other planets, that two, they never leave their celestial quote-unquote neighborhood. Mm-hmm. They're kind of always in the same place. They don't really behave as the rest of the planets do. Right,
like as all other planets tend to have this circular motion where they orbit.
Yeah. So one of the things is there's other dwarf planets out there within our solar system. There's actually 5 or 6 of them. I think it might be 6, but 2 of them that I know of are they're called Eris and Sedna, and they kind of behave the same way that Pluto does. So we know that it is a dwarf planet and not actually a planet. So they found this new one though, mm-hmm. out past Neptune. It's it takes 15,000 years for it to orbit the sun one time.
Holy crap.
So,
no
you
wonder
know,
we just found it.
Yeah, right. And right now it is not visible to telescope. However, it should be soon, even if it's a few years from now, but it should be sometime relatively soon that they will be able to see it from a observatory in Hawaii, where it's where they have the only telescope that is large enough to see a celestial body at that distance.
Huh.
So I'm kind of excited.
I can't wait to see that.
Yeah, right. So, they can already detect it, and they can already detect changes and influence on other things around it out there, from its movement and its orbit.
Now, do we know anything as far as if it has an atmosphere, or if it, if there's water on it? Is there, a lot of people is there life on there?
Well, we really don't know anything about that. So far, we know it's a gaseous planet because all of the outer planets are gaseous planets, which is another reason for the Pluto thing, because it was more like frozen, ice, sort of solid. But all of the planets, starting with Jupiter on out, are gaseous planets. So they say that it probably developed about 4.5 billion years ago, and settled into a distant elliptical orbit where it kind of still lurks to this day. And they're looking forward to finding out a lot more data about it once it becomes visible. It was discovered by Konstantin Batygin and Mike Brown from California Institute of Technology. So thanks to you guys.
Yeah, no doubt. So
good work. Keep going.
Yeah. Hopefully, we find out a lot more about this planet. That seems really interesting.
Yeah. Feed me more.
Yeah.
The best parts about it is that it's already detectable. Via satellite means and things like that. They know it's there. It's just not in a visible range yet, or a place where we can actually use a telescope to see it. And that will be coming up soon. So
we'll have to definitely do an update on that for sure.
Oh, for sure, yeah, for sure. Plus I wonder what they're going to name it, because the two that discovered it, they're the ones that get to name it.
Right.
Yeah.
Right now, isn't it just something like the?
Well, they're giving it all kind of names, like the new Planet X, or
the ninth planet.
Yeah, the ninth planet.
Or Planet 9, or something like that.
Yeah. So once they are actually able to see it and get visible confirmation that it's there, aside from satellite transmissions, I'm sure they'll come up with a name for it if they haven't already. They just maybe they didn't announce it yet, but I'll bet you those two have something in their mind of what to call it. Yeah. Okay, now we have also here some new news. Some news.
New news.
New news.
New news.
Current news. Even more than current. Now, this was discovered, by the way, in June, but they just recently released this.
Oh, okay.
That there's a supernova that they found, and they found it because it is the largest explosion in space that we've ever known of or recorded or documented.
Wow.
And so last June, this group called it's called the All Sky Automatic Survey, or ASAS. They discovered a faint flicker of starlight in an unmarkable galaxy, which that's one that's not even named or marked yet. But it's in the southern constellation of what is that? Oh, of Indus, which, by the way, is a constellation. It's only in the southern skies, I think, but it's an Indian. It's a constellation that is an Indian. So in the constellation of Indus, they they found this supernova, this flash of starlight, and it says hundreds of supernovae are discovered every day. This one, however, was different because once it was determined that the exploding star lay 2.8 billion light years away from Earth.
Holy crap.
You know, which is about 1,000 times farther away from us than Andromeda, which is pretty much the closest star system out there to our own. So it's so far away, really, that that they realized this little flash of light from that far of a distance is kind of, well, it's the biggest star explosion that they've ever seen.
Wow.
Because if it generated that kind of light from that far away, it had to be, enormous. So,
wow.
So as it goes, they figured that it was the biggest supernova blast ever seen. Okay, so they say it would have been, if it would have been closer to us, if it was okay, Alpha Centauri is is the closest star to us, but they said if it would have been as close as Alpha Centauri, when that blast happened, it would have been brighter than our own sun.
Damn.
Yeah, so go figure. That's a huge blast from that distance to be brighter than our sun is when we're close to our sun.
Yeah.
You know, because we're only the third planet back.
Right, and that's kind of scary, knowing a little bit about supernovas and, an explosion like that and the radiation that it would carry.
Right.
You know, if we had something that, we had a supernova that big, that would have been
as close as Alpha Centauri.
Right.
Yeah, it would destroy the Earth. It would destroy our atmosphere. First off, it would just completely rip the atmosphere away from the planet and cause an ice age.
like almost instantly.
It would definitely be an extinction level event. Yeah.
Yeah, and that's pretty scary.
Yeah.
I mean, knowing that however many light years away that is, well, you have that much of a chance to live,
Yeah. By the way, to this day, right now, that supernova that they're talking about, they say that it radiates more energy per second than all of the stars in the Milky Way galaxy combined.
Holy crap.
Yeah. Yeah, so go figure. We're lucky that's in a distant galaxy that is unmarked.
Really?
That leaves us safe. But even at that, even if it could reach here, it would take so long. Like,
we would be able to, extend our lives and, and live our lives and not really work. I mean, yeah.
oh man, you know what? Thousands or millions of generations of our children would be dead already by the time it ever even got around here.
Yeah.
So, thousands, hell yeah, millions and millions of generations after us would be gone by the time it would reach here. But, that's another thing when I get back to the fear factor of people who don't understand things and don't understand science. That's one of their problems with data and information like this. They don't want to know that because then they'll worry.
Right.
That,
the fear.
They're thinking that we're all safe here on this little planet and it's all flat and it's got the firmament. And blah, blah, blah.
It's all flat.
Yeah, so, yeah, now when I think of flat Earth, I think of Neil deGrasse Tyson's, his retort to that, which is hilarious.
Oh, yeah.
People should look that up on YouTube. It's great.
What was that on?
That was on The Nightly Show.
Oh, yeah, on Comedy Central.
Yeah, which used to be The Daily Show with Jon Stewart, but they named this one The Nightly Show.
Oh, okay.
It's because Daily Show's already been used.
Right, yeah.
So, they, the thing is we need Well, first off, when mankind was in its infancy, we needed to learn about our surroundings, our planet, where we actually physically lived, and what around it could give us nourishment and keep us alive, and what around it could be used to our advantage. And we had to learn the world around us. Well, now that we're a little bit beyond that, we have to learn about what's outside of the realm of our planet, and then eventually even beyond that.
Yeah,
We
well,
need to learn everything we can about everything.
Need to, especially now, considering with climate change, global warming, things like that, on how to protect our Earth and what we can do
Sure.
to keep it around for many generations more. Like
Yeah.
we don't, we've been kind of helping destroy our planet more than we've been saving it.
Yeah. Well, look at it this way: the waste of humans and animals and insects feeds the Earth.
Hmm.
When we breathe in, use oxygen, and exhale carbon dioxide, that is what the trees need to pull in. So it's supposed to work like this big harmonious natural machine, and we give things out that to us are waste, and these other things around us use those things to sustain themselves.
Hmm.
Now, if you can just keep that constant harmony going, everything should run fine, and we should really not have to worry about destroying our Earth or doing damage to it. Now, there are the things in nature, like volcanoes and whatnot, that do destroy things and kill people and pollute the sky for a while until it all settles down. But the problem is, we keep cutting down trees and plants and stuff and destroying nature lands and replacing it with blacktop and Walmarts and things like that. You know what I mean? So,
Yeah.
so we're constantly building things, and the more of nature you wipe away to put these structures of mankind there, the more damage that's doing.
Yeah, yeah. That's kind of what I was getting at with that. We have, even when you were talking about, with the coal burning for factories and stuff like that, and I mean that has a
Yeah.
lot to do with harming the ozone layer.
Yeah. Well, a lot of the things I don't get is, okay, in some religious texts it says that we have dominion over the animals and the earth and everything else,
Hmm.
which means that for some reason we tend to think as humans, and I'm not, speaking of any specific humans, but, mankind overall tends to be a little bit better than thou to whatever it is, to the earth or to the animals or to anything. We think we reign supreme for some reason.
Hmm.
This is not so. What we're doing is we're throwing everything out of balance, and pretty soon we're like, oh, why is everybody getting cancer, and where'd this new disease come from, and blah, blah, blah. Well, look what you're doing.
Right.
Where do you think it comes from? It comes from greedy humans that want, and want. It's one thing to take what you need from Mother Earth. It's another thing to just take. And, put yourself on a pedestal above all other living things. And I don't care if it's a molecule or if it's an animal or if it's a human or whatever it is. Whatever is on this planet is here for a reason. It's part of the balance. And when you start thinking that you ride higher than all other things on Earth, that they don't matter as much as you do, well, that's where you get the problems that we are having today.
Yeah.
And everybody, I hear religious people all the time, oh, we're at the end of days. Well, it wouldn't be that way if you hadn't done all this crap. You know what I mean? If you hadn't started burning fossil fuels, if you hadn't started ripping up all the grasslands and all the trees and forests and everything to build freaking shopping centers, maybe we wouldn't be in such bad shape. So,
Right.
so with me, it's not about going against one side or the other. It's about keeping the balance.
Hmm.
That's the main thing. We need to keep the balance. We need to put things back in balance because right now it's way out of balance.
Well, that's all we have for this show. Thanks for watching Reason is Reality. I'm Jay.
I'm Steve.
And before we go, I'd like to let you guys know that we're going to start a Patreon site, so you guys, if you do like us, you can support us on there. And also, stay tuned for a new segment coming up called Q&A with Steve and Jay. So make sure that you turn in your questions, and we'll be answering them on the show. You ask your questions on Facebook, here in the comments down below. You can follow us on Twitter and ask your questions there. Or if you'd like to do it by email, you can reach us at reasonisreality@gmail.com. Thanks for watching.